Let's see the fourth question. So the fourth question over here is to create a multiple regression by choosing some of a data set, either an online or the used one, and do an EDA and check whether the R square and RMSE has increased before and after, before to after. So yeah, let's see the demo part of this. So over here, I have imported the necessary libraries. So which I have used over here: NumPy, Panda, Seaborn, and Cyburn, SciPy Stats, and Matplotlib for visualization, Seaborn for visualization, NumPy for computing, and Pandas to read it in the tabular format and to perform operations to that, and other scikit-learn libraries which I had to use. So this is the data frame called graduate, and the CSV is admission product, and this is the first few records, and data types. These are the data types for each of the column. So I saw that serial number there is no significant use that a model can learn, so I have removed it. And also this is the shape. We have 400 rows and 8 columns, and I renamed the columns so that it is useful for manipulating the data frame or doing some operations on it. So this is after that, and I have verified that there is no null columns. So there is null column, so this is what it is, and I have just to cross check, I have even dropped it. And I have did standardize the graduate graduate and TOEFL by subtracting with the mean and dividing with the standard deviation. By doing this, we are saying to the model that these two particular columns are equally important as the other columns. So we standardize those. This is how it is, and this is after the standardization. And I have seen the data distribution of GRE. So one of the column is GRE over. This is the data distribution of that column, and this is the data distribution to check what's the range in which a particular range has more data in that frequency. So this is for TOEFL and this is for CGPA. So I did a correlation for all the columns, and over here are most of them everything are numerical, qualitative, so quantitative, so all of them are numeric. This is how it is. A pair plot, I've used a pair plot in C1 where it shows the similar one which we saw in this number format. It is visualized in this graphical way, and I have verified the correlation for each of the attribute. The first one which I have taken over here is GRE, and the target variable is over here as chance. So GRE versus chance. We can see here, we can plot a regression plot by seeing this, and the Pearson correlation is also 0. Less than 0.05, which says that is a significant value. And this is the residual plot, so which means that the errors should be equal to the mean. So this is the mean value. The values which are above 0 and below 0, if you sum up it will be 0. The same thing I did for TOEFL with the chance, and we see there is a straight line, and the Pearson coefficient is also less than 0.05, and this is the residual plot. The same thing goes with the CGPA and SOP. While going with the SOP, I see that it is not that consistent, whereas comparing it to the first three. University rating is also the same, the research is also the same, the Pearson coefficient is not that significant. So starting, I have performed multiple regression for all the columns except the target variable, which is chance over here. So X has all the columns and Y has only the dependent column. So it has all the independent and dependent column. The shape is 407. So if you see, before it is 8, now it is 7. So shape is just the chance. So this is what it is. So here where I initialize the linear regression and I fit the training data, and I have predicted on the unseen data, and I see that MSC is around 65%, and R square is also 81%. R square is 81%. So here I have just taken the first four most significant correlated variables with the chance, and we see that CGP and GRE, TOEFL, and university rating as the high among every them of among the every other attribute. So X is being those three variables, and Y is that dependent variable, and this is the shape, and this is the data shape we have at the after doing the correct columns, selecting the correct columns. And same thing, I refitted the linear regression, initialized the linear regression, fitted the training data, and these are the coefficients intercept just to see. I added it, and I predicted on the unseen data the MS is 65% and R square is 81%. There is not much change compared to before and after, but by the CDA process I identified the most correlated things by using regression plots and residual plots. With this, there is a little improvement in the R square, whereas MSC is almost similar. There's the points and difference. Earlier it is 64, now it is 65.5. Yeah, this is all of the fourth question. Thank you.